So let's talk about some of the engineering and perhaps the main technology behind a couple of your other solutions. So
Mhm.
your company is best known for medical devices for detecting malaria in blood. Tell me more.
What we bring to the table is our understanding of optics and photonics and um, using that on different applications. So, I mean, the really brilliant people are the people who are putting that into applications, and those are our customers. And so that particular customer that you're referencing was a spin out from the Massachusetts Institute of Technology, and they had won a bunch of business plan awards and had a very inexpensive way to detect malaria in the blood by using some magnets that reacted with malaria markers in the blood, and that you could get a different optical signal. So they engaged with us to design and build that system that had the magnetic field that created um, created a differentiation that was different between blood that had malaria and blood that was malaria free that you could use as a diagnostic. So that was about 8 or 10 years ago, and I think they're still working on that technology. It hasn't reached mass market success, and that happens. Some of our products go on to sell millions of units, and some of our products, for so many different reasons, that a product would succeed or not succeed, and that one still hasn't found its home yet.
Okay, so let's go to another one. What part did you play in designing lenses for self-driving cars?
In the mid 2000s, maybe early 2000s, the defense agency that does technology in the United States, called DARPA, did a contest for people to drive a fully autonomous car through kind of a desert, through some sort of course. I don't remember what year the first challenge was, but in my recollection, nobody actually succeeded at getting a car to do that. But one of the entrants was these people, Dave Hall and Bruce Hall, who had a really good system called LiDAR, which was put on top of those cars, their entry. And that module that they built was better than what anyone else was doing for creating maps of the environment to inform the car. So they wound up starting a company called Velodyne and selling that LiDAR technology to all kinds of automotive suppliers. And they eventually went public, and they've had their ups and downs since then. But, when they were in their early stages, before they'd really built out a full engineering team, they engaged with us to, design some of those lenses that were sending the laser light out and then collecting it after it had been in the scene and come back to their photodetectors. So that was sort of optics, and I would say optomechanical design, because in any sort of lens design, if it's multiple elements, it's very important to hold all the lenses correctly. And so that was the work we did for them.
Mhm. Another one is the optical treatments for brain cancers.
Yeah, so that's a newer one, and that's just a spin out from a university. Well, actually, there's a couple of them, but there's different people working on different applications for the brain, and one of the applications is a patient will ingest some kind of fluorescent marker, and then that fluorescent marker in their brain then fluoresces a bit during the surgery to allow the surgeon to better see what tissue needs to be removed and what tissue can stay. And so there's some, optics around imaging that area through a camera, getting the right fluorescent transmission. And then there's also some research from a different client about that actually maybe there's certain kinds of benefits for using fluorescent light to treat parts of the brain cancer that were not removed. It's interesting as well because one of the tasks that we have to do is figure out, well, how does light move through brain tissue, and what other materials are in the brain. And what research out there tells us that if we shine an LED light at this particular wavelength, is it going to be absorbed? Is it going to bounce around? Where is it going to go? How do we design optics to take that LED light and direct it to where we want it with as much efficiency as possible? So, there's a lot of kinds of systems like that where, particularly looking at the human body, whether it's you're looking at skin or, the eye, that there's, you can only sort of get so far with optical modeling and design because people just don't have all of this information, and people haven't really done the research to figure out all the characteristics of this. And, even if, there's a lot of companies doing, diagnostics or treatments of things of the skin. And, people's skin is different. They have different pigmentations. It behaves differently at different ages in life. You could have different kinds of, things on your skin that have different optical properties. So, there's just a lot of research that's still going on, and kind of, I would say, human, how the body responds to light, and how human physiology works with optical systems.